So Gareth, if you're ready, I'm going to go ahead and switch screens and make you a presenter.
Sure. Let me there we go. Show my screen. Can everybody see that?
Yep, I can see it.
Okay, let me start my presentation. There we go. Alrighty, well, good morning everybody. My name is Gareth and I'm going to be your MC, shall we say, for this little trip through the Fangorn Forest. In case you don't know, the Fangorn Forest is an area in Middle Earth that is involved in the Lord of the Rings, and it is home of the Ents, and the Ents are tree people. And basically the way that I tie it into ColumnStore indexes is that the tree people they stand upright, as opposed to the hobbits, which are short and run around the ground. And that's where that comes from, kind of. As you'll see, we'll tie it in a little bit later as well. But ColumnStore indexes are new in 2012, and if I can get there we go. Here, this is the agenda, what we're going to talk about today. We'll quickly go over a little bit about me, and then we'll go into the basics of ColumnStore indexes, look at the key characteristics and how they actually work. Then we'll do a demo, and then we'll do some wrap-up on basic best practices, data types, restrictions, that sort of thing. You know, things, do's and don'ts of ColumnStore indexes. Alrighty. So this is me. My name is Gareth Swanepoel. That's how you pronounce that, and I'm from South Africa. I normally don't use my last name because my first name is unique enough. And I came over to America in 2001 from South Africa. I worked at various companies on various technologies in South Africa. I went to university from 1990, did a computer science degree, and been working in IT ever since. I am now a DBA consultant here at Pragmatic Works. I joined them last year, about a year ago, and I'm really enjoying getting involved in all sorts of things that our customers are doing on SQL Server. I'm glad to say that the book is now finished. I wrote 3 chapters in the upcoming 2012 Professional Administration book. I wrote performance tuning and optimization and optimizing T-SQL chapters. There's my contact details. You can go see my blog and follow me on Twitter, and there's my email address if you have any questions. One thing I didn't put on there is I have ridden a cheetah, which was our fax this morning, and if you would like to hear the story, just email me and I'll let you know what happened there. That was quite a good time. Okay, ColumnStore indexes. Traditional indexes on tables are what's called row store indexes. Basically, when you define an index on a table, you define the columns that are present in that index, and SQL Server goes off and physically copies the data in those columns into that index. If it is a clustered index, then it copies all the columns, because then it just orders the table by that index. If it is a non-clustered index, it actually copies those columns out into a separate area into the index for that non-clustered index, and it is stored in a row. So all the data for each row is stored in that non-clustered index. ColumnStore indexes, on the other hand, are actually stored columnar, where the data for each column that you specify is physically copied, and only the data for that column is copied. As you can see here on the right, it increases the efficiency of the index, because only the column, each column is stored separately, as opposed to where all the columns are stored together in a row store or a B-tree index. One thing that is new with this ColumnStore indexes is that the columns are incredibly compressed. Where there are multiple values that are the same, the ColumnStore index actually only stores one of those values and has a reference that tells it exactly which rows are relative to that value. So they're incredibly compressed. Now, in a data warehouse database, the data sets are very large, and there's a huge urgency to read and process all that data very quickly. The data has grown much faster than the performance of underlying machines has grown. Nowadays you're getting data sets in the order of terabytes, and CPUs and memory and the speed of the machines really hasn't kept up with this increase in data volume. And not to mention that the expectations of the businesses nowadays has increased even faster than the data has. One of the things that we've noticed that has come out of what you can call the economy or the state of the world at the moment is that businesses are looking more and more at their data and how they can utilize their data. And we've actually seen an increase in data warehousing because of that. And BI is becoming much more important for businesses. So the expectation of the business on the data set has grown exponentially. And ColumnStore indexes has been introduced in 2012 to try and alleviate this problem because of the we're going to look at higher performance and better efficiency on the data set itself. Now, ColumnStore indexes is a technology that has been used in other databases before, and SQL Server has been able to introduce it in this way, and it's been designed to satisfy these very large data warehouse kind of data sets. Aggregations, summations, specifically star join queries, that sort of thing, on very large data sets. You're not typically going to have a ColumnStore index on a small table, pretty much because the increase in performance it's going to be there, but it's not going to be enough. When you've got a data set of a terabyte or two and you've got a table that is 1 billion rows, that's where you're going to get the performance increase. If you're trying to try and increase a query from 10 to 20 seconds by using ColumnStore indexes, sure, it'll work, but why are you only going after 10 seconds? You know, if you've got a increase from the order of magnitude from minutes to seconds, that's where you're going to look at ColumnStore indexes, and that's where it's going to give you the most benefit. So, for example, on the difference between a row store and a column store index is where you've got a fact table. Let's say a fact internet sales table, and you've got columns of sales amount and order quantity, and you want to do an aggregation on those columns. Traditionally, what you would have to do is you'd have to do two things. Either you'd have to calculate a sum every time you run a query against a specific column, say sales amount or order quantity, and you'd have to get the result set of that and then work with that. Or you could go and actually physically build a summary table which has the aggregation in it, and that is what analysis services pretty much does in a cube. But if you've only got a small data set that you don't need to use analysis services, then you're going to be building these little summary tables yourself. And the management overhead of all these little tables, because you've got a summary table for each specific column, that is just total overhead, and it's really unnecessary now with the new ColumnStore indexes, because ColumnStore indexes will actually almost do that for you. So let's have a look at some of the key characteristics of ColumnStore indexes and delve a little bit deeper into them. First of all, as you can see, that the first characteristics is the columnar data set, the data format. Each row of the table is stored, each column of the table is stored separately from each other. And when you do a query, only the columns that satisfy that query are retrieved. That gives a performance increase immediately. Secondly, we have no key columns. So all the columns in the data they all reference exactly the same. And within a normal index, you're only allowed to have, or any table, you're only allowed to have 16 key columns. Well, there's no key columns in ColumnStore indexes, so you can have as many columns as you need in there. As I said, faster query results because only the column that is needed for the query is retrieved from disk. Now, typically in a data warehouse query, the query only uses 15 to 20% of the columns in a fact table. Most of the columns in a fact table are important but not used when you're doing reporting. There's a lot of, first of all, key columns. There's a lot of foreign key columns. There's a lot of, description columns, that sort of thing. So when you've got ColumnStore data indexes, your query is much quicker because you're not even returning all those columns. Partitioning is definitely supported. Partitioned. Can everybody hear me? And I saw my audio connection disappear.
We can hear you now. You're back. Hey, Gareth.
Well,
Hey, you're breaking up a little bit here.
I'm breaking up a little bit?
Yeah.
Wow. Like I said, I was hoping that my network would be fine. I've got a hard wire in here.
Now.
Okay.
Okay.
What did you miss? Partitioning?
A little bit.
Okay. With partitioning, the base table is partitioned and the ColumnStore index can be set up on that base table. But the partition column has to be one of the columns of the ColumnStore index. You can't build a ColumnStore index and not include that partitioning column. The index record limit on a table in SQL Server 2008 and 2012 is 900 bytes. Because ColumnStore indexes store every column separately, that limitation is not there. It's not in effect. It does not apply. Now, along with ColumnStore indexes, SQL Server 2012 introduces two other new concepts. The first is the concept of a segment. Now, if a table is partitioned and you define a ColumnStore index on that table, within each partition, SQL Server will break up that partition into 1 million row segments. Each segment has metadata stored with it and has a minimum and maximum value for that segment. So let's say that you have a ColumnStore index on a zip code column in a fact table, and you've got all these orders from all sorts of areas in the country. It's a national, say, internet sales table. When you place a ColumnStore index on that zip code column, it'll actually go and arrange and order that column, and every column is ordered individually. It will go and, like I said, it will compress by just saving each individual zip code, plus it will do these segment breakups on that column. So that if you do a query and you only need, say, zip codes in New York, for example, it'll go and read through that table, it'll see which segment will satisfy that query, and it'll only pull the data from that segment. I see we have a question. The question is, can we control the sort order of the ColumnStore index? No. That is controlled by the database engine itself. I hope that that helps us a lot as well. So the segments that are implemented on ColumnStore indexes help a lot with with query processing because you're going to only be reading in the data for the specific segment that's going to satisfy the query. There is another question. The mechanics of how the ColumnStore index, the question is, how does the ColumnStore index link individual rows within each column? What are the mechanics? Well, that is something that is internal to the SQL Server engine, and they haven't even released any information on that. So I don't know. But I can go and find out for you, Jonathan. So I'll get back to you on that. The second thing that ColumnStore Indexes has introduced with SQL Server 2012 is a concept known as batch mode processing. Now, I don't know if anybody here watches American Chopper on TV. I enjoyed the original American Chopper. The new stuff with it's basically a soap opera is not so fun anymore. But the way that those guys build a motorcycle is very interesting. What they'll do is they've got 3 or 4 guys, and you can think of them as 3 or 4 CPUs or cores in a CPU, and they'll go get the gas tank and the other tins and a handlebar and the forks and all that, and then put them all together, and ultimately they'll have built a motorcycle. And one guy will be working on the tins, and one guy will be working on the wheels and the chassis, that sort of thing. And that is similar to the way that SQL Server processes a query. It'll go off and it'll return the rows out of one side of the join, and it'll get all the rows for that side of the join. And then it'll go and get a lookup against another table, referencing those rows by key to that other table, and it'll go get the result set from that. And then maybe there's an aggregation or a comparison against that, or maybe a where clause that they have to filter out results. And that's the way that SQL processes a query, and it normally works pretty well. But when you've got a data set that is 800 million rows or billion rows, that takes a time. And with ColumnStore indexes, they've introduced batch mode processing, which is very similar to what Henry Ford did when he introduced the rolling production line to produce cars, where a chassis will start off at the production line on the one end, and there'll be one guy standing there, and he's got a whole pile of parts, and he'll just put wheels on it, and it'll go off to the next guy, and the next guy will just put the body parts on it, and it'll go off to the next guy, and the next guy will just put the steering wheel in, and maybe the electrics and that sort of thing. And in general, the car actually gets built much quicker on a rolling production moving assembly line than it can be done with just 3 or 4 guys working in a sequential way. And that's what batch mode processing will do. It'll take 1,000 rows of data at a time, and that is a hard-coded number within SQL Server, and it works on these 1,000 rows of data at a time and moves the results to the next area that needs to work on those 1,000 rows of data. Now, remember that ColumnStore indexes are designed to work on large table aggregations and star joins and that sort of thing. Batch mode processing can speed up those queries, and they have found orders of magnitude of 70 to 40 times. Obviously, it's not going to increase a little query that you've got against, find me all the products that are red, and join it and try and find some customer name, in a table. That's not what ColumnStore indexes are designed for. They will increase the performance on those, but the real power of this is going to be in your big table aggregations and summations. Now, as you can see there is a problem with ColumnStore indexes. In the current release of SQL Server 2012, which is now pretty much RTM, a table with a ColumnStore index on it cannot be updated. And some people will say, well, that is going to make me not even go to ColumnStore indexes. Well, when you look at the way that data warehouse systems work, you're pretty much only doing read-only stuff during the day. you've got your ETL process that does a load at night. So one of the ways that you can overcome this for now is that you can drop the ColumnStore index, you go and load up your new data, and then you can rebuild the ColumnStore index. And the rebuild of the ColumnStore index is very quick because it's not like a brand new index on a table where the database engine has to go and physically order all the data and copy everything to another area, and it's all the rows in the table. Your ColumnStore index is individual rows at a time, individual columns at a time. So it goes and pulls that column out and then does its very quick compression and ordering and aggregation work on it, and then moves to the next column. And it's actually much, much quicker to build a ColumnStore index on a table than it is to build a normal index. There is a question here from Rakesh. Can I build a ColumnStore index on a view? You know, I haven't actually come across that, and I will have to go and check that on you. I'm going to make a note. You know what? I do have it. It's right at the end. No, you cannot build a ColumnStore index on a view. I'm sorry. Mainly because I think that they're going, that if the underlying table changes, it's not going to populate down to the ColumnStore index. That's what I think. But no, you can't build a ColumnStore index on a view. Getting back to updating the table, the second way that you can actually update a table really that has ColumnStore indexes, and this is a bit of a workaround, is to partition the table. You can have a staging table. You build the ColumnStore index on the staging table, and you have the ColumnStore index on the existing table, and then you just switch partitions. Does everybody understand how to switch partitions like that? Basically, you just you have a full table and maybe it's got 12 partitions, and you build a staging table and you insert data into the 12th partition, and all you do is you switch partitions, number 12 for number 12, and all it is a metadata change. It's not an actual data move, and that is very quick. It happens sub-second, and your new partition is then within the table. So you can do that. And that is the recommended way of doing that. Hey Jeff, the question is, if I have to rebuild, then how much time does it take to build an index? I'm not exactly sure in the order of, say, billions of rows, but on my little VM, we'll see it in a little bit. I've got a ColumnStore index on a table that's probably 7 or so million rows, and it takes about a minute. So I haven't tested it on a big machine yet, but it's definitely much quicker than building a normal index. The third way that Microsoft has recommended to kind of try and get around not being able to update a ColumnStore index table is to have basically two tables. And you have your main table, which has all your static data, and you have a smaller new table that has got the updated data. And when you do a query, basically you're going to query the data out of the main table, and then you query the data out of the little table. The main table is using ColumnStore indexes, so the performance increases, and all the benefits of ColumnStore indexes come from that table. And the little table maybe has up to 10 or 20 million rows in it, so it does return the data pretty quickly. And then you get the results out, and you union them all, and away it goes. That is the third way that you can get around this problem. But the problem with that is that your small table is going to grow, and eventually you're going to have to do some maintenance and take all that data and populate it into the main table again. And that is a manageability headache, but like you would not believe, eventually. Alrighty, so what we're going to do now is we're going to get into a demo. So let me flip over to my VM. I hope everybody can see that. And we're going to open up my Management Studio. And we're going to have a look at, here I have my Data Warehouse, AdventureWorks Data Warehouse 2012 database. And I have some tables in here. And you can see that this thing's a little slow. Then I have two tables here. One is called the Factory Reseller Sales, and one is called Factory Reseller Sales with that I'm going to build the ColumnStore index on it. And if you can see, the size of the data here is about 7.8 million rows, and the index on a normal Factory Reseller Sales table is about 3.5 gig, right? And the table itself is 1.8 gig. Sorry, I'm just trying to get my thing here. So what we're going to do is I'm going to open up these tables, go and have a look. I've already created a ColumnStore index on the table here, and I can show you the code that I used for that. I just created you say create non-clustered ColumnStore index on that table, Factory Reseller Sales CS, and you specify the columns that are going to be included in that index. And in general, you include as many columns as you like. Some people will include all the columns. I do have a best practice on which columns to choose later in the webinar, so we'll go over that. If we look at the other table, Factory Reseller Sales Basic Table, this table has all these standard indexes that come with AdventureWorks when you install the default sample databases. And they include things like employee key and order day key and all of this good stuff. So they do have covering indexes for the queries that we're going to do. I have a question from Jeff that says, can I have a ColumnStore index without the underlying row store fact table? You can put a ColumnStore index on a heap, sure. You don't have to have any other indexes on the table. But remember that ColumnStore indexes are only non-clustered indexes, so you can't try and make it a clustered index. So the underlying table will still be a heap. Okay, so what we're going to do now is I'm going to show you some of the performance increases that we get with ColumnStore indexes. I'm going to set my statistics time on and my statistics IO on. And let's select distinct from a reseller product key from Factory Reseller Sales. And this is going to take a while because, I mean, it's a 8 million row table on a VM running on my laptop. And we'll be able to see what the data is when it comes back, and then we'll be able to see the performance increase when I do it against the ColumnStore index table. So there it ran in about 25 seconds, and if we look over here, it did about 55,000 logical reads. Okay? Now what I'm going to do is I'm going to do this.
Hi everyone. Hi everyone. Please bear with us for a second. I know we're having some audio issues. One moment please while we try to get them resolved.
Nope. There we go. Am I back yet?
Yeah, you're back.
I saw my audio disappeared there for a while.
Back.
Okay. So let's go back to, I'm going to clean out the procedure cache and the buffer cache, and then I'm going to do the same. Select distinct product key, and product key is one of my ColumnStore index columns from my ColumnStore table, and this should come back in a minute, in 1 second, and it only did 524 logical reads. That is much quicker. Okay, let's go and have a look at a little more in-depth query. This query is a sum of sales amount, and we're going to look at a specific order date, and we're going to order by sum, all that good stuff. Let's clean out the procedure cache and everything, and then let's first of all, let's go and have a look at the estimated execution plan here. And you can see here that this, what it's going to do is it's going to do a table scan. It has to do that because it has to do a sum, and it has to collect the top 10. Okay? Then it does an aggregation, compute, and then it does a top. But it has to do this major table scan. Let's get that running. And that's going to take a while. So I'm going to have a look at some of these questions. Question from Jeff. I'm asking, oh Jeff, sorry, you're asking if the data is duplicated. You understand that the ColumnStore is greatly compressed? Yes, the data is duplicated in the way that when a ColumnStore index is placed on a table, it copies the data and puts it into a compressed ColumnStore column separately from the underlying fact table. I hope that helps your question there. Alrighty, so while we are looking at that, there's more. If it compresses, would it remove the duplication of the data in the table? Yes, that's how it compresses it. It basically stores one value in the ColumnStore index for each value in the underlying table. And then it has a reference that says which rows are referenced by that one specific value in the ColumnStore index. Secondly, there's another question that says, are there primary keys on the tables that you are querying now? There are no primary keys on the fact reseller sales. I think it's because there's no clustered index on these tables. As you can see here, oops. There's no clustered index on those tables. So when we did this query here, we got the sales amount. I mean, it's just one number. That we got back in about a minute, and it did 228,000 logical reads. 228,000 read-ahead reads. And that is on the standard fact internet sales. So what we're going to do now is we're going to drop our FreePod cache, drop buffers, and we're going to go and have a look at the estimated execution plan for the ColumnStore index table. And if you look over here, it does a ColumnStore index scan, and that is only on that one specific column. It's only going to do an index scan on that one specific column that it needs. On the predicate, and then it's going to do a hash match and a couple of other computations, but this returns, let's run this query, this returns in 1 second, and it did 1,600 logical reads and 2,900 read-ahead reads. So it is much, much more efficient, and there's much better performance using ColumnStore indexes. Let's have a look some more at the questions over here. It said, Jeff says, so the optimizer is smart enough to know if accessing a row store is best or if a column store is best? Yes. In fact, certain times, if it looks at the kind of query that you're doing and the ColumnStore query is not going to work, or batch processing is not going to work, it's going to simply revert back to row processing. So the optimizer will go and try and use the ColumnStore index first, if it is there on the table, and if it's not able to, then it'll drop back to the row processing. Daniel says, do you have the foreign key from the dimension tables? I'm not sure what you are looking at there, Daniel. On the ColumnStore index table, there's no foreign keys at all. So it'll help if you do put foreign keys on there, I'm sure, but you don't need to. Alrighty, so I hope everybody enjoyed that. That shows you how much performance increase you're going to get, and that's, like I said, just on my little laptop. So on a major machine, and you're doing some really heavy billion row aggregations, that's really going to increase your performance like you wouldn't believe. Alrighty, let's go back and do some more looking at our... Always do that. Let's go and look at some of the best practices and things to go over in ColumnStore indexes. First of all, when you're choosing your columns, the best practice from Microsoft is choose as many columns as possible. There's no increased query overhead because all the columns are stored separately. You can get increased performance because the query is only going to use columns that it needs. So it doesn't have a performance increase on actually using as many columns as possible. You might have a bit of a hit when you're creating the ColumnStore index, but technically I think it's better to do a little bit more work in the beginning at ETL time, where you're going to get the performance back on your query and reporting time. In general, you don't really want to have a ColumnStore index on a string column, such as descriptions or foreign keys or something like that, basically because those aren't going to be ever queried anyway. And if you need that data, then the query optimizer is going to go back to row processing and go fetch that data for like descriptions and that sort of thing. So you don't really need to have a ColumnStore index on those tables. Compression works best. The compression in ColumnStore indexes works best on numeric columns and columns that you're going to do aggregations on, postcodes, that sort of thing, zip codes, because it's going to have a lot of duplicated values, that sort of thing. Okay, do's and don'ts. First of all, do put ColumnStore indexes on large tables. This is going to be your fact table and very big dimension tables. Like I said earlier, if you're going to try and tune a query down from 30 seconds to 20 seconds, ColumnStore indexes might help, but that's not where you want to spend your time. You want to spend your time on trying to get queries down from minutes down to seconds, that sort of thing. And ColumnStore indexes are going to help on really big tables like that. In the reporting and in your query processing, that sort of thing, you really want to structure your queries as star joins with grouping and aggregation as much as possible. If you're going to join a large fact table to smaller dimension tables, you can use standard inner joins. But you really want to use that as star joins as much as possible. There are a couple of don'ts, mainly because they're not going to give you the performance increase that you need, because when you use things like outer join and union all, the outer join and the union all actually cause the query optimizer to drop to row processing and not be able to use the batch processing because of the way that query, the data is returned. Jeff says, if you say no outer joins or union all, and the user does perform these actions, yep, the optimizer will use row processing as opposed to batch processing. Don't use filters directly on the columns in the ColumnStore. String filters actually don't get pushed down into the scans on ColumnStore indexes. filters on numbers and date types are pushed down. So if you're going to try and do queries on those kind of keys on tables that have strings, it's best to use values or integer codes or surrogate keys or something like that. You can move those string values like a description off to a dimension table and then do joins on those. Andrew says, would ColumnStore benefit when select star happens, as in when analysis services is processing all fact records? Yes, I believe that it would, because of the additional benefits of things like the batch processing. Obviously, when you select star, you're selecting all the columns anyway. I'm not sure if the optimizer will drop to row processing at that point, but I believe that it should stay with batch processing depending on what else you do with that select star. And lastly there, don't use a not in with a subquery within on tables with column store indexes, because that will cause the system to drop and revert back to row processing, because it can't get the benefit of batch processing. However, if you do a not in and then you put a list of constraints, then the batch processing will typically work fine. Okay. Data types that are supported in column store indexes, character and varchar, except for varchar max and varchar max. Those are not supported at all in column store indexes. You actually get an error. Decimal is supported, as well as all your number types, int, big int, float, bit, all of those, and all date and time data types are supported, except for date time offset with a scale greater than 2. Okay, unsupported data types, binary and var-binary, images and that sort of thing, end text, varchar max and varchar max, I said, things like unique identifier, SQL variant, decimal with a precision greater than 18, CLR types, and XML. Those are unsupported in column store index. If you try and create a column store index on those columns, you will get an error. Restrictions on column store indexes. First of all, there is a SQL limitation to the number of columns, and that is a number of columns in any table, and that is 1024 columns. Like I said, column store index is not a clustered index, it's a non-clustered index, and it cannot be a unique index. So you can't say unique in the definition of a column store index. You cannot create it on a view or an index view, and you cannot include a sparse column. You cannot make it a primary key or a foreign key on the column store index columns. You can't say alter index, you can only say create index, and you cannot create, and you cannot have included columns. And sorting is not allowed because the system does the sorting itself on those indexes. And those are the restrictions on column store indexes. These are references that I have used to basically get most of my information. There are some other websites and articles, but I will be putting this presentation up on my website, and we'll have it available, the recording, at pragmaticworks.com. So let's go and see if there's any other questions here. Has anybody else got any other questions? I don't see any that I haven't answered, except let's see, go here. Philip says that his son's also named Gareth. Well, that's a great name, but everybody thinks his name is Garrett. Yes, because Gareth, the original true Welsh pronunciation of the word, is very, very uncommon in America. It is, however, common in England and South Africa, so I'm glad I'm a little unique. Does anybody else have any other questions on... Oh, there was a question about, is 2012 ready for download? Yes. They actually last week announced the RTM version. You can go to Microsoft.com and you can go download an evaluation version, which is the full RTM code. It is an evaluation version which will only last for 180 days. The full RTM is going to be available on the 1st of April for download on probably MSDN and TechNet and all that sort of thing. Jeff says, since a ColumnStore index is not supported, you can only compress horizontally. It is sorted, but you can, when you define it, you can't say how it's got to be supported. It is, how it is sorted. It is sorted within the database engine, and you can't say whether you want it sorted ascendingly or descending. It sorts it itself. What is the limit of fragmentation to rebuild the ColumnStore index? Well, because you're not updating ColumnStore index, there's no fragmentation. When you create the table and you create the ColumnStore index, it's going to sort it and build the ColumnStore index with no fragmentation. You're not going to ever update it, so there's not going to be any fragmentation introduced. Does it work only in 2008? No, it doesn't work in 2008. It only works in 2012. If the columns are sorted, then they may get better compression. They do. They are sorted and they get a lot of compression. And that is one of the strengths of ColumnStore indexes. Mr. Gonzalez says, is it best practice to create one ColumnStore index with many columns? You only allowed one ColumnStore index on a table, I believe. And you're going to include as many columns as need be. Would the underlying database ever become columnar like Vertica? The database is not going to become columnar like Vertica. You can create a ColumnStore index on a database that has Vertica implemented, but it's not going to cause that database to become like that. I hope that answers everybody's questions. Let's have a look and see if there is... Well, can we include multiple aggregate columns in one ColumnStore index? Yep. Yes, you can. In fact, every column could be an aggregate column, if you feel so inclined. Jeff says, sounds like this implementation is better because the optimizer can choose row or column store based on the query. Yes, it is really powerful in that way. And that's one of the cool features about this. I hope everybody has a chance to play with all this new 2012 stuff. And like I say, we are offering a training classes. So if you guys do need training on more than this, then you can email me or email sales, and we'll get right on that for you. Thank you, Jeff. Thank you, everybody.
Thank you, Gareth. That was a wonderful
session. That was interesting. And
it was great. Yeah, I learned a lot. And as always, everyone, this has been recorded. So if you missed any part of it, you can always go to pragmaticworks.com and go to webinars and view past recordings. And this one should be posted by tomorrow. So thank you, everyone, and I hope you guys have a great weekend.
Yep. Enjoy your weekend, guys, and we'll speak to you again soon.
Thanks, Gareth.